Hello, good evening, good evening, good evening, good evening to all the grade 12 students. Welcome back to one more session of your WOC. So, this is your Imam back again with day 3 series. Yes, you heard it right, students. We have started the final revision for your board exams. That is the last 30-day strategy. Correct? I have already done yesterday, that is day 1. In that particular day 1, I have done two series, two videos, video 1 and video 2. So we have started with your solutions chapter. So today let us further proceed. As I've mentioned, I'm going to tell you the most and short numericals for your board examinations, which are going to come in solutions chapter. So please watch the video till the end, and I promise you'll be getting more than 98%. Let's start the video. So basically, in this particular series, I'm going to deal with all the 10 chapters, and in that, I'll be dealing with multiple choice questions, very short assertion reasoning type, content based, analogy type, and some important previous year's questions. So I've already done this in day 1 series. I have also done very short answers in day 1 or day 2 rather yesterday night. Now today I'll be dealing with short answer questions. In this I'll be dealing with 2 marks questions. I'll be dealing with 3 marks questions. I'll also be dealing with assertion reasoning type today. Alright students, let's start. As I mentioned, my request is please watch the videos. I have done one short videos. So please watch all the one short videos which are kept in the playlist. Everything line by line NCERT is covered. Also, please watch handwritten notes. I have sent 9 chapters handwritten notes. Please watch that handwritten notes also so that it is easy for you all to write the board exams. Because I have taught answer writing skills in that. And most important, not the last, believe in yourself, students. Believe in yourself. If you believe in yourself, you will be the best person on this earth. Let's start. So today, as mentioned, let's start with the assertion and reasoning type questions. Then I'll be going into once again, students, I'm getting a call, please. Sorry. Okay, let me pause the video once. All right, now let's go back, students. As actually, I just got a call. Sorry for that. So let us read the answering and reasoning type question here. What did they say? They said relative lowering in vapor pressure is a colligative property. That is assertion concept. In reasoning concept, they have given relative lowering in vapor pressure depends upon the mole fraction of pure solvent. So these are the two concepts which they have given. Now they've given me a question where there is one option A, option B, option C, and option D. So I have to justify whether the assertion is correct, reason is correct, whether reason is explaining the assertion concept or not. So let us justify gradually. So first question is relative lowering in vapor pressure is a colligative property. Okay, let us see. So relative lowering of vapor pressure, that is nothing but RLVP, right? So relative lowering of vapor pressure, this is the formula. Okay, this is what you have studied. On which one this is depending? This is depending upon XB. What is XB? XB is nothing but number of moles of solute. Correct? No, it is number of moles of solute, not solvent. Correct? And this is what we have studied. XB is, it is only solute but not solvent. Okay, easy. Chal. Now we also said colligative property is something which depends upon the number of solute. So colligative property is number of. Now as you've seen the formula, yes, RLVP is depending upon number of solute. Let us go back to the question and see. Is assertion correct? Relative lowering of vapor pressure is a colligative property. Yes, assertion part is correct. Reason? Relative lowering of vapor pressure depends upon the mole fraction of pure solvent. Oh, this is the problem here. This is a wrong statement. So which supports this? Where is assertion true? Assertion is true here. Assertion is true and reason is false. Because complete reason is false because here this depends upon mole fraction of solute, not solvent. So the correct answer is option C is the correct answer. Clear, students? Let's go back to the next question. Easy? Easy. Next, let us read the next question. Osmotic pressure is a colligative property. The next reason, osmotic pressure is proportional to the molality. Oh, right. So let us reason this and see. First of all, osmotic pressure. What is the formula? Pi is equal to CRT. Okay, right. What is pi? Pi is equal to N2 divided by V into R into T. Now what is N2? N2 is nothing further expanded W2 by M2 divided by V into RT. Now you only see what is this W2? W2 is weight of the solute. Correct, na? Weight of solute in grams. What is M2? M2 is a molecular weight of the solute in grams. Correct, na? In grams. Now you only tell me, both are related to the number of solute particles. So colligative properties are something which depend upon number of number of solute particles. So assertion, yes, it is correct because it is depending upon number of solute. Let us go to the reason now. Osmotic pressure is proportional to the molality is what they said. Okay, simple. It's nothing big. I mean, where is molality here? Let us reason that. So now you remember, students, first of all, suppose I'm in diluting a solution on in dilute solutions where there's more amount of water. In dilute solutions, what will happen? Concentration is less. What is more? Dilution is more. When dilution is more and concentration is less, what happens? See, normally in your molarity or molality, see, normally your molarity concept and molarity concept, what is the difference? In molarity, rather, if I have to see, I'll be writing it is number molality. I'll be writing number of moles by weight of solvent in kg. This is what I write, weight of solvent in kg. But in case of molarity, what do I write? Number of moles by volume of solution in liters. This is what I write, right? This is what I write. Now, what happens is when you're diluting or when your concentration is reducing, when your dilution is increasing more and more, automatically your molality will become equal to molarity. Remember this. Yes, what happens when your concentration is decreasing and dilution is increasing, your molality will become equal to molarity as I said, more of dilution is there. The weight of solvent means you're increasing more and more dilution. Means both the numerators are same and here it will go to a dilution part. That's why at this particular point molarity and molality will be equal. Let us go back and see. That's reason. Yes. Osmotic pressure is proportional to molality. Is it right, students? Yes, it is right. Now let us go back. As assertion and reason are true and R is a correct explanation of assertion. Is R talking about colligative property? Directly is it talking about colligative property? No, it is not talking about colligative, but it is saying it is dependent on molality. Let us see the next option. Assertion and reason are true, but R is not the correct explanation of A. Correct, because it is explaining separate concepts. So option B is your option B is your correct answer here because it is not talking about colligative, but it is telling us on what it is dependent. Done. Next option, next question. This is also done. This is an empty page. As I said, let us summarize. On dilution, your M will become equal to capital M, or C, your concentration will become to M. Simple as that. You see, next question, students. Given, let us read this. When NaCl is added to water, a depression and freezing point is observed. Okay, the lowering of vapor pressure of a solution causes depression and freezing point. Now let us understand what is NaCl. NaCl is a non-volatile solute. Non-volatile solute. Okay. When you add non-volatile solute, what will happen to the vapor pressure? Yes, students, because here non-volatile solute and the vapor pressure where water is present, automatically because of this, the vapor pressure reduces or decreases. Correct? Now, in the presence of non-volatile solute, the vapor pressure reduces or decreases. Correct? Now, they are asking when NaCl is added to water, depression and freezing point is done. So, freezing point, how is that freezing point related? Let us understand that. Okay, right. Now, let's see. Now, what happens when, first of all, your what actually is freezing point, students? Freezing point is nothing where a liquid solvent, okay, a liquid solvent in solution, it will be in equilibrium. It will be in equilibrium to what? It will be in equilibrium to solid solvent. Right? Is it right? The liquid solvent in solution will be in equilibrium to solid solvent, solid solute rather, both. So at FP, what will happen at freezing point? Only the solvent, whatever is there, only solvent will get converted to solute. This is okay. Done. So what will happen? That amount of solute, whatever is remains, it remains unchanged. So that the amount of solute, whatever is it, so solvent, it gets converted to solute, and the concentration of the solution, what will happen? It will start increasing. Yes or no? Once again, at freezing point, both are in equilibrium. Okay. So what happens? Only the solvent will get converted to solute. So what will happen? The amount of solute, whatever was there earlier, remains unchanged. Okay, now if this remains unchanged, what will happen? The concentration of solution now increases because here also you have solute, here also you have solute. So the concentration of the solution increases. Now come back and say, so what does it mean in case of your particular freezing point concept? In case of freezing point concept, I have to remember but the what do you say, the non-volatile, or the vapor pressure is decreasing. Vapor pressure is decreasing means the freezing point also is decreasing. Correct? That means your solid or the liquid solvent, whatever is there, it's getting converted to solid solute. This is what is happening. Now go back and understand the concept and answer this. They said when NaCl is added to water, depression and freezing point is observed. Is it so, students? Is it so? It happens? Yes, it happens. Just now you have seen. The lowering of vapor pressure of a solution causes depression and freezing point. Yes, both are interrelated. So can I go and mark the first option? Assertion and reasoning are true, and R is a correct explanation for assertion. That is the concept there. Easy? Easy. Let us go to the next question. When methyl alcohol is added to water, boiling point of water decreases. They're asking, giving me the assertion part. Next reason, they said, when a non-volatile solute is added to a volatile solvent, elevation in boiling point is observed. Okay, now careful. First of all, let us answer this. Methyl alcohol is added to water. What is methyl alcohol, students? Methyl alcohol or methanol? Okay, methanol. What is it? It is a volatile liquid. Or rather, if you have to say volatile solute, can I write? Volatile solute. Okay. Now what happens? I'm adding this volatile solute, methanol. I'm adding, let me take up a page. Sorry. Let me take an eraser, please. Okay, so I'm adding this methanol, which is a volatile solute, to where I'm adding to a beaker containing water. So I'm adding it to water. All right. So when you're adding it to water, this is also volatile. This is also volatile. So what will happen? What will happen? Automatically, both the volatile liquids, boiling point of water, whatever is there, it's going to reduce. Decreases because both are volatile. Both will evaporate faster. So with less boiling point, I can boil it. Yes. So when will this happen? At low temperatures. So the water will start boiling at very, very low temperatures. So when boiling point at low temperatures, you tell me, will there be any change or elevation in boiling point? The elevation in boiling point is not observed because at low temperatures only they're getting evaporated. So elevation in boiling point is not observed because both are volatile liquids. Go back to the question and see. Let us answer the question. When methyl alcohol is added to water, boiling point of water increases. Does it increase? No, this is also volatile. This is also volatile. Why will it increase? It will decrease. So the option is wrong. When a non-volatile solute is added to a volatile solvent, elevation in boiling point is observed. Yes, this is right, Mr. Kunz, because when non-volatile solute is added to a volatile solvent, what happens? In this case, non-volatile solute, whenever you're adding, automatically the elevation in boiling point increases because the vapor pressure, whatever is exerting on the surface of the liquid, it makes the boiling point increase. Correct? So that's a reverse. So non-volatile, it will increase elevation in boiling point. In volatile, there is no increase in boiling point. That's done, students. Easy, very easy. So very important assertion reasoning questions. Now let's start the 2 marks questions quickly. I'll be doing more next video also. So 2 marks questions, what did I do? All the 2 marks short questions I have given in the form of question and answer. So directly you can learn this. You can learn the same answer, learn the answer exactly, and you can answer and you can write this in exam. You'll be getting write this in the exam. You'll be getting full marks because this is the way you should write in the exam. So Raoult's law concept I have been given here. Next, list out ideal conditions or ideal solutions must satisfy. Like that, I have given 2 questions here, students. Question and answer is given. You can directly write the same answer in both the cases. After that, some more azeotropic questions of azeotrope concept, non-volatile solute concept. Both the questions are given. I have already done the videos for this, so please watch one-shot videos also. So for you to study before the exam, I have given the answer. Gradually from there, 2 marks, 2 more questions I have given. Antoff's factor as well as the osmotic reverse osmosis concept also questions I have given. Learn these 2 marks questions, it will be done. From there, further, depression freezing point, one small numerical for 2 marks I have given for all 8, 9, 10, and the answers also I have given here to note it. So after the complete 2 marks, now I'm going to give you the 3 marks questions and short numericals. I have listed out all the short numericals. So basically 1 3 marks question, very important students, short numericals are compulsory you'll be getting. So Henry's law constant numerical, how is the procedure given, how you are going to apply in the question, how you're going to write the units and everything is given. So please practice this. I've already explained these questions in the one short videos. From there, gradually, I have gone to one more simple question. Define ideal solution and write its characteristics. That's done. From there, I've gone to one more important numerical, very important for calculating the molar mass. So using RLVP, they'll be asking you one question which is based on calculation of molar mass. This is one concept. Let us see one more concept. Using your relative lowering of same thing but units will be different. Again, they'll be asking you to calculate molar mass using the Weber pressure concept. After that, using your elevation and boiling point, they'll be asking you to calculate the temperature. At what temperature will the water boil? What temperature? So this concept is important. What temperature the water is they're going to boil. This concept is compulsory for you in elevation and boiling point. Next important thing from there, as we said, now in the same boiling point, they may also ask you to calculate molecular weight. So the molecular weight concept is here using the melting point part, the boiling point part. So take this numerical. Any doubts, please ask me. From there, again, depression freezing point. This is also one more concept where they ask you molecular mass or the solute. Only difference is the units will be changing in all the cases. Gradually from there, if I go, this is an important question, graphical representation. So they'll ask you, explain the lowering and freezing points of water with the help of suitable diagram. So this is a part of your NCRT. So this question, graphical based questions are very important. Please practice this question. From there, gradually, when I go further, they'll ask you again, as I said, using your osmotic pressure. Now again, they'll ask you MB. So MB based questions are very important. Unit conversions are also important. Unit conversions. Okay, so carefully study this. After that, one more with Van 't Hoff's factor. This question is again famous question. So you can learn this and practice. Short, you'll be getting 3 questions from this. After that, again Van 't Hoff's factor, same. Short questions, students, carefully practice. After that, gradually, Van 't Hoff's factor, one more concept I've given to make yourself more practice. This is one more question. Take it. Then calculate the freezing point of solution, degree of dissociation based on degree of dissociation alpha. I have taken this question relating Van 't Hoff's factor. From there, one more question, Van 't Hoff's factor question, and azeotrope's question also I have taken. So important question, students. So this Van 't Hoff's factor and alpha compulsory, you'll be getting one question in the exam. So practice this. Further, again Van 't Hoff's factor, one more question for you all, because these are important. Further, more and more questions will make you more practice. Okay, so molecular weight question, one more. After that, graphical based question. Azeotrope, osmotic pressure, basic definitions I have given. Each carries 1 mark. So 3 marks question, no, each carries 1 mark. So practice this. And you can directly learn it and write the same in the board exam. Further, some more sums. Alpha, degree of association, here in this case, degree of association. Then osmosis and osmotic pressure concept. All right, so most important. Before we go to thank you, let me tell you something, students. Yes, so I'll be uploading videos on regular basis. As I said, students, videos will be carrying your MCQs, short answers, very short answers, assertion and reasoning type, content or analog based questions, and analog based questions, analogy questions, or previous year's board questions. So everything I am doing it only for your sake, students. One imam is not going to charge anything. But my request is, please watch the videos on regular basis. I'll be sending videos. Watch on regular basis. Please share the video on regular basis. Please like the video, because we take a lot of pain in preparing a video. Though working, we come back and we do this video only for your sake. All right, students. So I request all of you to share this video how much ever you can. Thank you so much for watching. Stay happy, stay calm. As I said, work hard in silence. Work hard in silence. All right, I'll meet you again with one more video tomorrow. Signing off. Bye bye. Thank you so much.